Hello everyone. Here we are going to see block 4, unit number 13. It is two-person zero-sum game. Structure of this unit is objectives, introduction, classification, definitions, basic concepts, solved examples, sum up keywords, and some terminal questions. First, let's see the objective of this topic. So game theory is an approach to modeling behavior in situations where the outcome of your decisions depends on the decisions of others. Game theory is the study of strategic interactive decision making among rational individuals or organization. It provides a mathematical framework for understanding the optimal outcome and what the trade offs are to achieve that outcome. We build models using game theory to help our clients make strategic and tactical decisions within the context of many possible scenarios and competitive responses. So, let's see the introduction of this unit. Game theory provides a mathematical framework for analyzing the decision making process and strategies of players in different types of competitive situations. The simplest type of competitive situations is zero person, zero sum game. These games involve only two players. They are called zero sum game because one player wins whatever the other player loses. As we have seen that the Nash equilibrium and the max min are two different concepts that reflect different behavioral accepts. The first is an expression of stability, whereas the second refers the notion of security. So, there are cases in which both lead to the same results. Next one is classification. It is broadly classified into three main types. First thing is a classical game theory. It focuses on optimal play in situations where one or more people must make a decision and impact of that decision and the decisions of those involved is known. Decisions may be made by use of a randomizing device like piping a coin. It focuses one question like what is my best decision is a given economic scenario, where a reward function provides a way for me to understand how my decisions will impact my result. So examples for this classical game theories are poker, and in military some strategic decision makings they have. That thing is also example for classical game theory. And negotiations. Next one is combinatorial game theory. It focuses on optimal play in two-player game in which each player takes turns changing in predefined ways. In other words, it is defined as the combinatorial game theory does not consider games with chance or randomness. Generally, two-player strategic game played on boards most change the structure of a game board. Examples for combinatorial game theories are chess, checkers, and go. Next thing is dynamic game theory. It focuses on the analysis of games in which players must make decisions over time and in which those decisions will affect the outcome at the next moment in time. It often relies an differential equations to model the behavior of players over time. Example for this dynamic game theories are optimal play in a dog fight and chasing your brother across a room. It is a real life example for dynamic game theory. Next, some definitions, basic definitions which are used in this units are two-player game is called a zero-sum game if the sum of the payoffs to each player is constant for all possible outcomes of the game. More specifically, the terms in each payoff vector must add up to the same value for each payoff vector. Such games are called constant sum games. Then a two-player game is a zero-sum game if for each pair of strategies S1 and S2, S1 means strategy for the player 1 and S2 means strategy for player 2. It is defined as U1 times of S1 comma S2 plus U2 times of S1 comma S2 is equal to 0. In other words, a two-player game is a zero-sum game if it is a closed system from the perspective of the payoffs. Each player gains what the other player loses. It is clear that in such the game, the two players have diametrically opposed interests. Next one is basic concepts of two-person zero-sum games. So, some important concepts are there. In that, first thing is a two-person game is characterized by the strategies of each player and payoff matrix. Second thing is the payoff matrix shows the gain, that is positive or negative for player 1, that would result from each combination of strategies from the two players. It is noted that the matrix for player 2 is negative of the matrix for player 1 is a zero-sum game. Next thing is the entries in the payoff matrix can be in any units as long as they represent the utility or value to the player. Next point is there are two key assumptions about the behavior of the players. The first one is both players are rational. Second one is both players are greedy, meaning that they choose their strategies in their own interest. Next, moving on to the solved problems. Example 13.1. Consider the two-player game appearing, that is figure in 13.1. They have given some values. A two-player zero-sum game have been given. We have to find the value of the game. So in this example, V1 is 1 and V2 is minus 1. That is the maximum strategy of player 1 is in the place M, and that of in for player 2 it is in orth place. The strategy pair M, R is also the equilibrium of this game. We have to check that thing. In other words, here we have a case where the vector of maximum strategies is also an equilibrium point. The two concepts lead to the same result. We have to check that point. In this game, for each pair of strategies, the sum of the payoffs that the two players receives is 0. In other words, in any possible outcome of the game, the payoffs one player receives is exactly equal to the payoff the other player has to pay. See here, player 2 it is LCR and player 1 it is TMB. The payoff function U of the zero-sum game is given in the figure 13.1, and the study of two-player zero-sum game since the pay of u1 and u2 satisfies this thing, that is u1 plus u2 is equal to 0, we can verify our attention to one function that u1 is equal to u with u2 is equal to minus u. The function u will be termed the payoff function of the game, and it represents the payment that player 2 makes to player 1. Note, this creates an artificial asymmetry, that is, player 1, who is usually the row player, seeks to maximize, and player 2, who is usually the column player, is trying to minimize, which is what he is playing, since his payoff is minus u times of s. The game in example 13.1 can therefore be represented as shown in the figure 13.2, and the game of matching pennies can also be represented as a zero-sum game. See here in figure 13.3, the payoff function u of the game matching pennies is given in the figure 13.3. Consider now the max-min value of the players in a two-player zero-sum game, and player 1's max-min value is given by v1 equal to max-min times of u of s1 and s1 comma s2, and player 2's max-min value is represented by v1 is equal to minus min max of u of s1 comma s2. U of s1 comma s2. Therefore, a game in strategic form with the max min and min max values are seen in this figure 13.4. Therefore, v is equal to minus max min times of u of s1 comma s2, and v is equal to minus min max time of u of s1 comma s2. The value v is called max min value of the game, and v is called min max value of the game. Player 1 can guarantee that he will get at least v, and player 2 can guarantee that he will pay no more than v. A strategy of player 1 that guarantee v is termed a max min strategy, whereas a strategy of player 2 that guarantees v is called min max strategy. It is that is the vice versa. The next, we have to calculate the max min value and min max value in various examples of the game. So see here in 13.5, matching pennies with max min and min max values have been given in this figure 13.5. In this game, v is equal to minus 1 and v is equal to plus 1. Neither of two players can guarantee a result that is better than the loss of $1. As these example indicate, the max min value v and min max value v may be unequal. So the inequality is clear from the definitions of the max min and min max. Player 1 can guarantee that he will get at least v, while player 2 can guarantee that he will not pay more than v. As the game is a non-zero game, the inequality v less than or equal to v must hold. Suppose S1 star is an optimal strategy for player 1 in a game with value v, then minimum of u of s1 star comma s2 is equal to v. Let us consider this thing, and therefore for each s2 belongs to s2, the following inequality is satisfied, that is u of s1 star comma s2 is greater than v. is greater than V. Next, moving on to the theorem, if a two-player zero-sum game has a value V and if S1 star and S2 star are optimal strategies of two players, then S star is equal to S1 star comma S2 star is an equilibrium with payoff V comma minus V. So see here, both S1 star and S2 star are optimal strategies. We have to deduce that U of S1 star comma S2 greater than or equal to V, where S1 belongs to S1, S2 belongs to S2. And one more thing is there, U of S1 comma S2 star less than or equal to V for all S1 belongs to S1. So here S2 is equal to S2 star in equation 13.27. We have to replace S1 is equal, S2 is equal to S2 star, and what do you get? U of S1 star comma S2 star greater than or equal to V. And we have to replace S1 is equal to S1 star in equation number 13.8. So we get U of S1 star comma S2 star less than or equal to V. So the equation V equal to U of S1 star comma S2 star as follows. So the above equations, that is 13.27 and 13.28, can be rewritten as U of S1 star comma S2 greater than or equal to U of S1 star comma S2 star for all S2 belongs to S2. Let it be equation number 13.29. And the second equation becomes U of S1 comma S2 star less than or equal to U of S1 star comma S2 star for all S1 belongs to S1. Let it be equation number 13.30. And therefore S1 star comma S2 star is an equilibrium with payoff V comma minus V. Hence proved. Then moving on to the next theorem, if S star is equal to S1 star, S1 star comma S2 star is an equilibrium of a two-player zero-sum game, then the game has a value V equal to U of S1 star comma S2 star, and the strategies S1 star and S2 star are optimal strategies. So we have to prove this thing. The strategies S1 star and S2 star are optimal strategies. Since what's given in the problem, S1 star and S2 star is an equilibrium. It is the proof for the last theorem, and no player can benefit by an unilateral deviation. Yes. So it is given by S of U of S1 comma S2 star less than or equal to U of S1 star comma S2 star for all S1 belongs to S1. Let it be equation number 13.31, and U of S1 star comma S2 is greater than U of S1 star comma S2 star for all S2 belongs to S2. Let it be equation number 13.32. Let me consider V equal to U of S1 star comma S2 star. We will prove that V is indeed the value of the game. V be the value of the game, as we all know that from equation 13.31, it is given by u of s1 star comma s2 greater than or equal to v for all s2 belongs to s2. Let it be equation number 13.33, and therefore v greater than or equal to v means from equation 4.60, it is there in the unit, fourth unit. We deduce that u of s1 comma s2 star less than or equal to v for all s1 belongs to s1. Okay, here this figure represents the coordination game. Yes, it represents the coordination game, and v bar less than or equal to v. Why? Because means it is always that case v less than or equal to v bar, we get v less than or equal to v bar less than or equal to v bar less than or equal to v. Yes, which implies the value exists and it is equal to v. The value exists and it is equal to v. Furthermore, from equation 13.33, we deduce that SI star is an optimal strategy for player 1, and from equation 13.34, it is proved that S2 star is an optimal strategy for player 2. And next one is sum up. In this unit, students have learned about 2% zero sum game and application of game theory, and some keywords have been given for you. First thing is zero sum game. The algebraic sum of gains and losses of all the players is zero in a game, and the player who is interacting in the game. Next one is pure strategy. It is a decision rule always to select a particular course of action. Particular course of action. That is what a pure strategy. And next thing is terminal questions. Some terminal questions have been given for you. You have to make use of it. Thank you. We'll see in the next unit.